Welcome back to Kapil Joshi tutorial. In today's video, we are going to understand one of the most important concepts in machine learning, linear SVM versus non-linear SVM. Support vector machine, as we know, that SVM is a supervised machine learning we already discussed in previous video. So it is a supervised machine learning algorithm mainly used for classification problems. So the basic objective of SVM is very simple. Find the best decision boundary that separates different classes of data. But what happens when the data cannot be separated using a straight line? Now that is where non-linear SVM and the kernel tricks become important. So let us understand both concepts using the simple diagram. Let's first look at the linear SVM shown on the left side. Here we have two categories of data. The green circular points represents category A, while the light green square points separates and represent category B. If we observe the graph carefully, the two categories can be separated using a straight line. The straight line is called the decision boundary or the hyperplane in SVM. The main goal of linear SVM is to find the optimal hyperplane that separates the two classes with the maximum possible margin. Now, what exactly is a margin? The margin is the distance between the distance decision boundary and the closest data point from each class. The data point that are closest to the decision boundary are called support vector. And these support vectors are extremely important because they determine the position and orientation of the optimal decision boundary. For example, suppose we have two classes of students based on their marks and attendance. So if a straight line can clearly separate students into two groups, such as pass and fail, then a linear SVM can be used effectively. So mathematically, a linear decision boundary can be represented as WTX plus B is equal to sub 0. This is the standard representation of linear decision boundary, where W represents the weight vector, X represents the input feature, and B is the bias. So the key idea of linear SVM is if the data is linearly separable, we can use a straight line boundary to classify it. Now let's move to the next right side of the diagram. Here the situation is completely different. We can see that the green circular point represents category A, and it is generally surrounding with the light green square points representing category B. Can we separate these two categories using a straight line? Answer is no. No matter where we draw a straight line, it will not correctly separate the two categories. So this is known as the non-linearly separable dataset. So how can SVM handle this type of problem? So this is where the kernel tricks comes into the picture. The basic idea behind the kernel tricks is to transform the original data into a higher dimensional feature space, where the data may become linearly separable. Think of it this way. That is, imagine the we have data points on a flat sheet of a paper and they cannot be separated by drawing a straight line. Now imagine lifting that sheet into third dimension. After transforming the data into this higher dimension space, so it may become possible to separate the classes using a plane. So we do not necessarily have to explicitly calculate this higher dimension transformation. So instead, SVM can use a kernel function to calculate the similarity between data points in this transformed space. So this is why it is called the kernel trick. So there are several commonly used kernel functions in SVM. The first is the linear kernel. It is useful when the data is already approximately linearly separable. And the second is the polynomial kernel. It allows SVM to create more complex decision boundaries using polynomial relationships. And the third is the radial basis function kernel, commonly known as RBF kernel. So the RBF kernel is one of the most popular choices for nonlinear classification problem because it can create flexible and complex decision boundary. Another option is the sigmoid kernel, which has a behavior somewhat related to neural network activation functions. The important point to remember is that the kernel determines how SVM measures relationships between data points and allow to model nonlinear patterns. So let's quickly compare linear and nonlinear SVM. So linear SVM is suitable when the classes can be separated using a straight line or hyperplane. So it is generally simpler and computationally less expensive. On the other side, nonlinear SVM is useful when the classes have complex patterns that can be separated by a straight line or straight boundary. It uses kernel function to work effectively with nonlinear data. For example, if we are classifying emails as spam or not spam, so a linear model may work well when the features provide a clear separation. But for complex dataset involving images, biological data, or highly nonlinear relationships, a kernel-based SVM may provide better classification. So the simple rule is SVM, linear SVM, straight line separation, and non-linear SVM, that is very complex separation using the kernel tricks. And the most important concept is the support vector, the data point closest to the decision boundary that plays a key role in defining the optimal hyperplane. I hope this explanation has made the difference between linear SVM and non-linear SVM clear. So if you found this video useful, please like, share and subscribe to Kapil Joshi tutorial for more machine learning and computer science tutorial. Thank you so much and thank you for watching, and I'll see you in the next video. Bye bye.